Well, hey there, geometry students. Welcome to our next notes, 3-4 Algebraic Proofs. A good idea would be to pause this video right now and copy down what I have written down in this table. That way, whenever I work through it, you can work through it with me, or you can just work through it as I work through it. You might need to be pausing the video a little more then. Okay? What we have today are some algebraic proofs. We're going to go through some algebra things, and we're going to give a name to something that you already know. You already know these properties of the equality and congruence. They're called the addition, subtraction, multiplication, division, distribution, and substitution property. You already do these. We're just putting a name to these. We're going to use these whenever we're working through some deductive reasoning things. If we're using deductive reasoning to go through a proof, we're going to need to know the reasons, and these are the reasons, okay? We also went through an example like this in class. So hopefully, first off, if we're given that A is equal to B, they have the exact same value. The addition property would state that if I add the exact same number to both sides, they will still be a true equation. So I'm going to say that A plus C is going to be equal to B plus C. Subtraction property, same thing. If I subtract the exact same thing, let me say A minus D is equal to B minus D. And this is the case if A is equal to B. The multiplication property, I can take something, if I have A and B, and I multiply both sides by C, they're equal to each other. And division property, same thing. So all I'm doing is just giving a name to addition, subtraction, multiplication, division that you already know. We just call them the properties of equality. The distributive property, rather, is we can distribute my A to both things. So A times B plus C is equal to AB plus AC. And then we have the substitution property. Substitution says that if A is equal to B, then B can replace A at any time. For example, if it says that X is equal to 3, what is the value of X plus 7? Well, if X is equal to 3, then 3 plus 7 is 10. It is just as simple as that. Okay, we've got a couple more. So again, you might want to pause this video, copy these down. These are a little bit longer. The reflexive property, symmetric property, and transitive property. Let's go through them. The reflexive property is that it's going to be the exact same, that A is equal to A. So if I have something that's the exact same, I call it the reflexive property. And then if I have angle A, angle A is not equal to angle A, rather it's congruent. So this would be called the reflexive property of congruence. And then down here the same thing, AB would be congruent to AB. So we'll sometimes see it written down, and so we want to give it the reflexive property. And the next one, then we have the symmetric property. It says if A is equal to B, then what? Well, symmetrical, I think of symmetry. It's going to look the exact same, but just flipped. So if we think of kind of like a mirror being here, okay, we'll flip it over that. If A is equal to B, then B is equal to A. This would be helpful sometimes if we want to reorder something. In the same way, if angle A is congruent to angle B, then angle B is congruent to angle A. And likewise with the segment, if AB is congruent to segment CD, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. You might also realize that these are all conditional statements. If, then, if, then, if, then. So we can see this going on and on in geometry. Would help us out. Last one is the transitive property. You have seen this called something else in the past. See if you can think of what it is. If A is equal to B, and B is equal to C, then I can say that A is equal to C by itself. This is exactly like what you've seen with the law of syllogism. If A is equal to B and B is equal to C, we can cut out this middle part. I can just jump, say A is equal to C. So in the same way with angles and segments, if I can say that angle A is congruent to angle B, and angle B is congruent to angle C, then I can just say that angle A is congruent to angle C. And likewise, if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then I can just jump and say that segment AB is congruent to segment EF. All right, so here's all these laws, these properties of equality and congruence. We're going to use those with something much like this. Once again, I do want you to pause the video and copy this down. This is the start of a 2-column proof. This proof is going to go through and give us statements and reasons. Okay, we're always given something, and it's going to say, hey, we want you to prove this. There might be a picture, so on and so forth. So this gives me angle AOC. Angle AOB is 2 times x plus 7 minus 1. and then angle BOC is 3x minus 5. It wants us to prove that the value of x equals 18. The best part about this is we're not having to find the answer. It already gives us the answer. We just have to go through and give justification for each step of the process. Okay? Again, you should have this all down. If it tells me that's given that that ray OB bisects angle AOC, bisects means again to cut in half. So angle AOC is being cut in half. This ray is cutting in half my angle AOC, so I have two congruent angles, angle AOB and angle BOC. We want to put that in some statements and go through and prove what it's asking us to prove. We always start with what's given. So it's given that OB bisects angle AOC. Okay, the reason we can say that again is because it's given. If you always start there, then we can go on the next step. Well, if that's true, then I already said that angle AOB is congruent to angle BOC. Angle BOC. All right, why can I say that? Why can I say that they are congruent to each other? Well, that's the definition of something being bisected. And again, this is not just because I tell it to you, but we know that by definition, bisect means cut in half, so therefore I have two things congruent. So the definition of a bisector lets us know, gives us reason to say that those two things are congruent. If they're congruent, we'll also know that the measure will be the exact same. So the measure of AOB would be equal to the measure of angle BOC. If the measures are equal to each other, why can I say that? Well, why can I say that they're the exact same? That's from the fact that they're congruent. If they're congruent, it means the exact same. So that's the definition. I'm going to abbreviate DEF, definition of congruence. All right? From that, I know the measure of angle AOB, and I know the measure of angle BOC, so I'm going to substitute what those are. The measure of angle AOB is given to me as 2 times x plus 7 minus 1. Now will be equal to the measure of angle BOC, which is 3x minus 5. Okay? I've said the word several times here. The reason I can do this is the substitution property. Substitution property. Okay? Then I got to go through and actually solve for the value of x. So my first step here is going to take the 2 and distribute. I got to just simplify the equation. Distribute that 2. So I get 2x plus 14 minus 1 is now equal to 3x minus 5. Again, the reason is the distribution property. And these are all the distribution properties of equality. I'm going to allow you to leave those off. You can just say the distribution property. Next, I want to combine the 14 and the negative 1. So I've got 2x plus 13 equals 3x minus 5. And the reason for that is I just simplified. Simplification can always be given for a reason if you are making things simpler. All right, now I have an equation I want to solve for, so I want to bring the x's to one side and the numbers to the other. If you bring the 2x to the right-hand side, that's okay, or you could bring the 3x to the left-hand side. It doesn't really matter. Some people like to always bring the x's to the left. That would be okay. I like to always keep my x's positive, so I'm going to bring the 2x over to the right-hand side. If I do that, I'm going to have 13 is equal to x minus 5. And the reason I can say that is I subtracted 2x over here. So that is the subtraction property. Okay? For some people, it would be beneficial if you actually show that step. So I'm going to think to myself, well, I need to subtract that 2x over, so I subtracted. That's the reason it's a subtraction property. Okay? Get the numbers on the same side, so I'm going to now bring that negative 5 to the other side. I'm going to add it, so I'm going to have 18 is equal to x, and the reason for that is the addition property. Okay? And then my last step, it wanted me to prove that x is equal to 18, not that 18 is equal to x. So lastly, I can write that I can write that x is equal to 18, and the reason I can say that is because of the symmetric property. Oops, sorry, you couldn't see that one as I wrote it. X is equal to 18 because of the symmetric property. It's the exact same thing. I just flipped it around. I made it symmetrical. So there it is, we have it. All right? I know this is a long example, and yes, I do want you to come to class with this. You can look back at this whenever we need to go through a proof. Thank you guys. Have a great day. Don't forget your WSQ.